Hello students. In today's class, we are going to learn basic chemistry. The basic chemistry. Remember that if you are going to appear for any competitive exams, your basics must be very strong, right? So, like in class 9th, you are going to appear for NSEJS. There are many other Olympiads also, right? There is NTSE also. So for any exam, any competitive exam that you're going to appear for, your basics must be very strong, and the chemistry always starts with the atoms, right? We all have heard about the atoms, but let's see in bit detail about the atoms. What are these atoms? So for now, just remember that they are the ultimate particles. They are ultimate particles of anything around us. What does this mean? This means that anything that you see around is made up of atoms. For example, if you talk about any building, right? Any building starts with the bricks, right? So can we say that bricks are the fundamental particle of the wall or the building? Same way, the atoms are the fundamental particle of anything that exists around us, anything which we call the matter, right? What is matter? We are going to learn very soon about the matter also. But ultimate particle is the one which, the building block basically, which makes up anything, right? So that's called the atoms. Now, so we know that first let's see quickly that atoms are made up of three major subatomic particles. They are called protons, electrons, and neutrons. So these three particles majorly makes up an atom, and since they make up an atom, so they are also called as subatomic particles, right? So protons, electrons, and neutrons makes up an atom. Fine. Now let's see about the protons, electrons, and neutrons. Remember that the protons will have significant mass as compared to the electrons. Now, what is the exact mass and all? We are going to learn in upcoming lectures, right? So they will have significant mass as compared to the electrons, and electrons will have the insignificant mass as compared to the protons and the neutrons, right? They will have the insignificant mass, while the neutrons will also have some significant mass, right? So whenever you are considering the mass of proton, neutron, or electron, whenever you are considering their sum, you can always electron the mass of electrons, right? Just do remember the mass of one electron is negligible as compared to the mass of proton or the neutrons, right? Talking about the charge, protons carry the positive charges, electrons carry the negative charges, but neutrons carries no charges, they are neutral. Fine. Okay. If you talk about the absolute charge is, if you talk about the absolute charge is the exact amount of charge that one of the particle or any particular particle will be carrying. So exact amount of charge that proton carries is plus of 1.602 into 10 raised to the power minus 19 coulomb. C is the unit of charge. C stands for coulomb, right? For example, kg stands for kilogram, and kg is a unit to measure the mass. Same way, C, which is coulomb, is used to measure the charges. It's a unit for the charges, right? Okay. Electrons carries the same magnitude of charge as one proton carries, but the negative charge. So absolute charge over the electron is minus of 1.602 into 10 raised to the power minus 19 coulomb, right? This is the magnitude of charge, 1.602 into 10 raised to the power minus 19 coulomb, but negative sign. What about the neutrons? Obviously, they will carry zero charge. If you talk about the relative charges, now what is relative charge? As the name suggests, in relation to something, in comparison to something. So if you see that the charge over magnitude of charge over a proton and over an electron is same, right? So whenever we talk about the relative charge of a proton, we talk it in terms of electrons with respect to electron, right? So a proton with respect to electron carries a charge of +1, while an electron carries a relative charge of -1, and neutrons again 0, right? Okay, both these charges are important, right? But quite frequently we'll be using the relative charges of the electron, but you should keep in mind the absolute charge values for a proton and for an electron, right? Now, we'll keep in mind about the relative charges. A proton carries a relative charge of +1, an electron carries a negative relative charges of -1. In terms of charges, neutrons carry 0 charges, whether it be the absolute charge or the relative charge, it carries 0 charges, right? Now, let's see quickly the structure of an atom. This is I'm telling you just the basic structure of an atom for now. Very soon we'll have a separate chapter on structure of atom, right? This chapter comes under the basic chemistry. These things you must know before proceeding to learn chemistry. Like the solar system, the central part is sun, and around it we have the orbits on which the planets revolve, right? This is our solar system. So in the solar system, we know that the sun is in the center, and there are planets revolving around the sun, right? I'm not showing you the exact number of the planets, right? Just this is the rough idea about the solar system, right? There is sun in the center, then there are planets. These white balls that you see over here, they are the planets. These planets revolve around the sun. Similar to this, there is a structure of atom also. There is a central part over there, right? And around it, you find the circular path, right? Around it, this is our solar system, and this is our atomic structure. How an atom is structured, right? Now, the central part of an atom is called nucleus, and the circular path that you see around, they are called orbits or shells, right? So central part is nucleus, and the circular path around it are called orbits. We can see that there is a resemblance in the atomic structure and the solar system, correct? Now, let's talk about the nucleus. Remember that the nucleus will contain all protons. P stands for proton over here, and neutrons. N stands for neutrons, right? So nucleus contains all protons and neutrons of an atom, correct? Okay, since nucleus contains all the protons and the neutrons of the atom, right? So shall we say that the net charge of a nucleus should be positive? Why positive? Can you give a logic? Right? Why positive? Because the nucleus contains protons which are positively charged and the neutrons which contains no charge or 0 charge. So effectively, whatever the charge over the nucleus will be there will be because of the protons only, and that charge of course will be positive, right? So the net charge over the nucleus will be positive. That is why central part is shown with a plus sign, correct? For example, if I redraw the structure of the atom, I draw the central part over here, I will simply put a plus sign over here. This denotes the nucleus, and around it we have the shells, right? Fine. Now particles residing in nucleus are called nucleons. The particles which reside in the nucleus are called nucleons, right? So all the protons, all the neutrons are nucleons. Each proton is a nucleon, each neutron is a nucleon, and taken together, all protons and neutrons are also nucleons, right? So this was about the nucleus. Fine. Okay. Can you just say one more thing? Can we just say one more thing, that we know that that's among the subatomic particles, just protons and neutrons contains the significant masses, right? Just protons and neutrons contains the significant masses. The third subatomic particle is electron, for which the mass is insignificant, right? So mass of electron is insignificant. We know that, right? It's insignificant as compared to protons and neutrons, right? As compared to the mass of protons and neutrons, the mass of an electron is negligible. And since all the protons and neutrons are in the nucleus, so can we say that the mass of an atom is because of nucleus? Right? So mass of an atom is because of the nucleus. Why? Because the nucleus contains protons and neutrons who are having the significant mass, right? Mass of the electron can be neglected when you are finding out the total mass of the atom, right? This is it's like the same thing. If you take a person over here, right? If you take this person, right? Now this person carry a bag in this hand. In this hand, this is a bag, and this bag weighs suppose 5 kilogram, right? Okay. And he is wearing a cap also. Just assume he is wearing a cap. I'm very bad at the drawing, so just assume this is cap over here, right? This is cap. He's wearing a cap also, and cap is very, very light. Just assume the mass of the cap is 0.0001 kilogram. Correct? The person himself weighs approximately 60 kilogram. Correct? So you see that over here, if you are going to take the total mass of this system, if you are going to take the total mass of this system, what are you going to do? So can I say that the mass of the whole system, which includes the person, the cap, this is cap, okay? Let me just remind you, this is cap. Okay, so mass of the whole system, should it be the mass of the cap plus mass of the person plus mass of the bag? Right? Now, don't you think that as compared to the mass of person and the mass of bag, the mass of the cap is not contributing much? It's negligible, right? So the mass of the cap is not contributing much. We can completely ignore when we are calculating the mass of the whole system. Same way over here, if you had to imagine this system, the cap, the person, and the bag, if you had to imagine this, so just assume that if the person is proton and the bag is neutron, electron over here is the cap, right? So can we also say that the mass of the whole atom, obviously if protons, electrons, and neutrons are making up the atom, the mass of one atom will be the mass of its proton plus mass of its neutron plus mass of its electron, right? We can say that. So we can ignore the mass of the electron over there. If we ignore the electrons, what are we left with? Are we left with just the protons and neutrons? Right? So mass of the atom must be because of the protons and the neutrons. But where do they live? They live in the nucleus. So we can say that the mass of an atom is because of the nucleus only. Fine. Let's talk a bit about the shells also. Shells or the orbits. Shells or orbits are the circular path around around the nucleus. They are the circular path around the nucleus, right? On this, electrons revolve. Electrons revolve around the nucleus, right? Fine. There's one difference between the solar system and the atomic structure, which is in the solar system, we know that there is just one planet on one orbit. But in an atom, one orbit can have more than one electron, right? We'll see that very soon. For now, remember that this is the point where the solar system and the atomic structure differs, right? Okay, fine. There's one more difference, which is a solar system or a galaxy will have a finite number of shells, but in an atom, there can be infinite number of shells. There can be infinite number of shells. Let's keep that in mind. Fine. Let's see how do we represent the atom. So, representation of an atom. How do we represent an atom? So, we represent any atom using its symbol. Usually the first letter is taken for the symbol. For example, hydrogen, right? The hydrogen atom starts with, you see it starts with H, so this hydrogen is represented by H over here. Oxygen starts with O, the first letter is O, so we take O as the symbol, but this is not always the case. Many times the Latin name is taken, and many times there are two alphabets taken, right? So what I mean to say over here is that you need a symbol to represent an atom, right? So any atom, in general, in any atom will be represented like this. Its symbol X. X is the symbol. For example, in this case, H is the symbol, O is the symbol. Similarly, for any atom, just assume X is the symbol over here. To make it more informative, you have to supply it with these two values, G and A. Now, what are G and A? G is called atomic number and A is called mass number, also called as atomic number. Right? Let's see about these two terms. What are they? So G is atomic number, we know that, right? 80 number, atomic number, fine. Now it's always equal to the number of protons. Whatever is the number of protons in an atom, that is its atomic number. For example, hydrogen atom is represented like this, right? I am not showing the atomic mass over here for now. We are discussing G, so let's see here. So does it resembles to this? The lower part over here is the atomic number. So this 1 is the atomic number. So we'll say that atomic number of hydrogen is 1. But is the atomic number always equal to the number of protons in the nucleus? So if I ask you what will be the number of protons in the hydrogen atom, we will directly say the number of protons is just 1 because the atomic number is just 1. Let's take another example. Oxygen is represented like this, right? This number, does it resembles to this? The lower part is always the atomic number. So what will we say? The atomic number of oxygen is 8. And should it be equal to the number of protons also, as the definition says, right? So number of protons in the oxygen is 8. Fine. Okay. Let's talk about atomic mass now. A is called atomic mass. We know that the atomic mass, the mass of an atom, is just because of the protons and the neutrons. Right? Let's learn one more thing over here to simplify, to understand it in a better way. First thing over here, can we say that A equals to the mass of the protons, right, plus mass of the neutrons? We know that mass of whole protons plus mass of all the neutrons in an atom, that will equal to the mass of an atomic mass or mass of an atom, right? We can say that, we know, because we can ignore mass of electron, right? Fine. Now remember that mass of one proton is almost equal to the mass of one neutron, and it's almost equal to 1 AMU. Now what is AMU? For now, all I can tell you is that AMU is atomic mass unit, right? It is atomic mass unit. This AMU is a unit to measure the mass, one of the unit to measure the mass. Like you have many units in to measure the mass, like for example, kilogram is there, gram is there, milligram is there, nanogram is there, microgram is there. Similarly, AMU is also one of the unit to measure the mass. For now, you can keep this in mind, that 1 AMU equals to 1.66 into 10 raised to the power minus 24 grams. Keep this unit in mind for now, that one atomic mass unit equals this much gram. Fine. Now, so mass of one proton is equal to the mass of one neutron equals to 1 AMU. Now, let's assume that suppose an atom has 10 protons, and just assume it has 12 neutrons. Let's assume that. Correct. Okay. If I have to find out the mass of the atom over here, should I have the total mass of proton plus total mass of neutrons? You should have that, right? Now, mass of one proton is 1 AMU, we know that. So mass of one proton multiplied by the number of protons, we can say that, right? Mass of one AMU is the mass of one proton we saw in the previous page, right? Into the total number of protons. Similar way, the total mass of n, should it be the mass of one neutron into the total number of neutrons, right? Correct. Now 1 into number of protons, does it become simply equal to the number of protons only? And 1 into number of neutrons, does it become equal to the number of neutrons only, right? And what does it equal to? A. So do we have a formula for the atomic mass over here? Is that the atomic mass is equal to the number of protons plus number of neutrons. Do we need to tell you about the unit? Of course, the unit should be what? In AMU. Why in AMU? AMU, because whatever mass over here that you have taken 1 and 1 over here are in AMU, right? So atomic mass will be equal to the number of protons plus number of neutrons. So if I ask you about this particular atom, what will be the mass number? Can you directly say the total number of protons, which is 10, plus total number of neutrons, which is 12? 22 is the atomic mass of that particular atom, whichever atom is containing 10 protons and 12 neutrons, right? Now we are about to arrive on a very interesting relation between A and G. We know that A is the number of protons, P is the number of protons, and N is the number of neutrons. We know that. Okay, total number of protons and total number of neutrons. Can we also call it total number of nucleons? We can say that. Right. Now, we know that G equals to P. Total number of protons, we know that atomic number is equal to the total number of protons. Now, if you have to look at these two equations, A equals to the proton plus neutron and G equals to protons. So, can we say that A equals to, can I just substitute G for P, total number of protons in an atom, right? So, we can write A equals to G plus N, or atomic mass equals to atomic number plus number of neutrons. We can say that, right? Okay. Now, if you have to find out the number of neutrons, can we have this formula? N equals to, you take G that side, will it become A minus G? Atomic mass minus atomic number gives you the number of neutrons. So we can say that number of neutrons equals to atomic mass minus atomic number. Let's try to understand these two concepts through some questions. Fine. So over here, so for example, helium is represented like this, 2 and 4. This is the standard G and A, right? This is how we represent any element. The lower part is called what? The atomic number. So what is the lower part over here for the helium? 2. So can we say that atomic number for helium is 2? And atomic mass for helium, the upper part is atomic mass. Can we say it's 4? Now, G is 2. So can we say that helium has 2 protons? We can say that because atomic number is always equal to the number of protons, right? Now, A equals to 4. If somebody asks you, find the number of neutrons, how will you find it out? Can we directly use this formula which we have learned on the previous page? Atomic mass minus atomic number. So number of neutrons will become 4 minus 2 equals to 2. That means helium has 2 protons here and 2 neutrons, right? About the electrons, we will learn soon in the next video. Fine. Now, let's take another example. Let's take sodium. Na is sodium. Over here, Na is the Latin for natrium, right? Okay, it's sodium. Remember, it's sodium. Okay, so can we directly say, without thinking much, can we say that the lower part over here is the atomic number, and so the number of protons is also 11 for the sodium, right? Because atomic number is always equal to the number of protons. Fine. Now, the upper part is 23 the atomic mass of the sodium is 23 AMU. Unit will be AMU, remember? Now, if I tell you to find the number of neutrons in the sodium, what will you do? You will simply use this formula, atomic mass minus atomic number equals to 23 minus 11. That means sodium has 12 neutrons. Fine? Okay. So that's all for this particular lecture. In the next lecture, we'll see about the electrons also. How do you find the number of electrons and all? The next lecture will be even more interesting, right? And all the video lecture over here is very, very important for NSEJS or any competitive exams or any Olympiad you are preparing for. Even if you are preparing for IIT JEE, if your long-term goal is IIT JEE or NEET, your basics should be very, very strong. Right now, I will tell you what you should do, what you should start doing as homework for like to stay ready for any competitive exams. So remember, just memorize or by heart all atomic number and atomic masses till zinc, till atomic number 30. You should remember it. You should be able to tell the atomic number and atomic mass of any atom till atomic number 30, right? That will help you a lot. Okay, so that's all for the day. Soon we'll be available with the second video.